Good afternoon, everyone. We are Hawks Coastal Design, and we are tasked with a Sowams Road Soil Bank Stabilization Project. Our advisor is Dr. Judge, and my name is Ali Abdul Sader, and I'm a senior civil engineer.
My name is Ashley Bossy, and I'm a senior environmental engineer.
My name's Adriana Cesiri. I'm a senior civil engineer.
I'm Maeve Dragalis, and I'm a senior civil engineer.
And my name is Vincent Newbert, and I am a senior civil engineer. So what is the purpose of our project? Sowams Road, located in Barrington, Rhode Island, has been listed as a site of concern by the Coastal Resource Management Council, the CRMC. The soil embankment that is directly adjacent to the roadway, which is directly adjacent to the Palmer River, is being eroded away by the tidal erosion and the weathering, and is very much a concern for the town of Barrington. So we have been tasked with coming up with a dual-phase design in order to combat these problems. So some of the short-term concerns that we have, like I said, are the tidal and runoff erosion. We saw that one of the utility poles along the road is currently being disturbed, and the disturbed stabilization of the soil embankment. Some of the long-term concerns that we have are the undermining of the road, the extensive amount of erosion, and the flooding that can occur during large storm events, and possibly during high tide events due to the low elevation of the road.
During this project, we have been in contact with the Barrington Town Planner, and in January, Dr. Judge was able to go to a meeting in order to represent our team. During this meeting, the town of Barrington said that their top priority was to protect the use of Sowams Road, and that their idea for the design of this project was to have 2 or 3 phases in order to let it evolve with the sea level projection increase. For the cost of the project, they're requesting funds from the state, which allowed our team to put anything we found fit into the design. From the Barrington Resilience Plan, the top hazards were coastal flooding, storm surge, and sea level rise, and in order to protect themselves against that, they considered flood control projects for the low-lying sections of Sowams Road, as well as putting the power lines underground.
NOAA predicts that there will be about 11 feet of sea level rise in the next 80 years in the northeast region of the United States. Based on this, it can be estimated that sea level rise will be approximately 1.65 inches per year in Rhode Island. Using Storm Tools, a software recommended to us by the CRMC, a map showing rough estimates of sea level rise at our site was created. This map highlights key years in our design plan. We estimate about another 2 feet of sea level rise can occur at our site before flooding the road, and we are aiming for a 50-year lifespan. As you can see, the expected sea level rise for these timeframes expands far beyond our site. Additionally, an environmental site assessment was conducted for our site to determine if soil or water contamination was of concern. On the left, you can see a map of our site where they're marking the nearby landfills and gas stations. There are no landfills or gas stations near our site, thus limiting the concern for soil contamination. Also, the EPA has not reported any Superfund sites in the town of Barrington. The map on the right shows 12 water quality testing locations along the Palmer River in 2002. According to the Palmer River Water Quality Analysis Report, there are consistent elevated levels of E. coli, enterococcus, and nutrient counts. These high counts are the result of land use and are a concern for the entire region. Therefore, we are suggesting additional testing be conducted before implementing our design plan. For more information regarding the ESA, you can look at the supplemental report.
To give a better understanding of what exactly our design options look like on our site, we created these cross-sectional AutoCAD sketches. So this would be our short-term design where we're recommending moving the utility pole, which is currently in danger of falling over, to the other side of the road, underground actually into utility lines, and in doing this, we'd be taking away a street light. So we had to add another street light on the left side of the road because there is residential housing in the area. And also, we would be regrading the area to a lower angle, which will help stabilize the embankment, as well as adding geotubes under that soil to also increase the stabilization of the embankment. We would also be adding riprap on top of that, which will help break up the wave velocity and lower the impacts of the tides. So an important thing to note is that the elevation of the road is around like 6 to 7 feet currently, which is pretty low. And at high tide, the water line elevation gets to around 4.5 feet. So it's not a lot of margin between the water line and the road. So we recommend monitoring this water line throughout the entirety of the project. And once it gets to around 6.5 feet, to the point where it starts flooding the road during normal storm events, then we recommend implementing the long-term solution. So for our long-term solution, we are recommending a concrete seawall, which is not our first option because it is over-engineering for the current situation. But eventually it will become necessary due to sea level rise, because the lifespan of our project is around 50 years. So at that mark, a 50-year mark, this sea level will be around 11 feet elevation at high tide, which will obviously overcome the road, which is around 6 to 7 feet elevation. So at this point, we have to add a concrete seawall, which we currently put at around 5 feet, which will protect the road and the residential housing to the left. But obviously at that point, with sea level being that high, as you can see in the NOAA maps, it would kind of flood the whole lower area of Barrington in that area. So they would obviously probably have less use of Sowams Road and less use of the residential housing next to Sowams Road. But we do recommend monitoring that waterline elevation throughout the entirety of the project.
This is a cross-section view of our site modeled in a slope stability software called SlopeW. The picture on the left shows the current conditions of our site with the silty sands, and that the factor of safety of the slope is around 5.3. The picture on the right shows what the new factor of safety would be with regrading with poorly graded sand at around an angle of 30 degrees. The regrading would lower the factor of safety to 3.5, and with the limitations of our student license, we are unable to add in the future design structures that we plan on having, but we're confident that they would not lower the factor to be below 1.5.
So from the information gathered from our designs and from what Adriana talked about, the slope stability, we came up with an Excel sheet in order to quantify all the different design options and characteristics that we have chosen specifically. Using the Army Corps of Engineers manual, we were able to use that as a guideline and go through the steps that they laid out for the design of revetments, seawalls, and picking out different types of riprap. As an example of our Excel sheet, we calculated the max run-up, which gave us the best idea to which kind of riprap stone we should use for our specific site. And as you can see from the calculation, the run-up in feet for quarry stone is 4.4 feet, and the crest elevation is 9.4 feet, which is lower than the other two options that we considered. So quarry stone, in this case, would be our best option. The Excel sheet also let us quantify volumes for the regradation and volumes for the concrete. And it helped us to come up with a cost estimate, as Maeve will talk about later in the presentation.
Implementing shoreline vegetation would create a coastal buffer zone in between the developed residential area by the road and the embankment. It would reduce the runoff velocity of storm runoff from the road and protect the slope from the top rather than just from tidal surges like the riprap does. Vegetation traps sediments and pollutants, which will improve the water quality in the area. Common types of vegetation used are trees, beach grass, flowers, shrubs, and vines. And in our case, the beach grass would seem to be the best option. URI has a database of native Rhode Island vegetation that you can filter through to find out which would be best for our site based on the site's nature characteristics. Having this feature would be a good natural design that the CRMC would like to see.
So this is the short-term material cost estimate that we have created for the town of Barrington. It includes drainage, vegetation, utilities, non-living erosion protection, and living erosion protection. Under drainage, we're included upgrading the culvert. Under vegetation, we have the beach grass. Under utilities, we have the relocation of the light poles to the other side of the road, as well as putting the power lines underground. For the non-living erosion protection, we have the soil for the geotubes, the regraded soil, and the riprap. And under the living erosion protection, we have oyster reefs. Most of the companies that we have for the cost estimate are local to Rhode Island in order to keep business local, as well as the transportation costs down. The total estimate is $270,000, which includes the price of the items marked up to 15% just in case the cost estimate does increase over time. These are our references. Are there any questions?